6 years ago, I made my first ever software-related public talk right here at TDC. So it feels like coming back home. And I always encourage people to do more of public speaking, sharing your stories. You are the expert of your story, so they always have something to share. And you create this bond with the first conference that ever gave you a chance. So it's really special to be here. So I'll be sharing today with you my story about 3 of the principles that I value or hold dear or respect that were challenged at some time. And we'll start with doubting those principles. So when we doubt something, you ask questions. So hopefully, at the end of the talk, I'll leave you with a set of questions for you to be able to apply in your own context. And let's start with some questions. So that were the real motivation for this talk. Why am I using domain-driven design, test-driven development, and so on? So what is the reason behind these principles that I use as a guideline? Is it really necessary to have deep domain understanding in every business case? And what about architecture? You know, there is always an architecture, whether or not you make your explicit choice or the implicit choice. There is always a choice. So what justifies the choice? And there was this perspective of code reading, like code writing and code reading are 2 different things. So what about when we read code? How much is it required from us to understand? What are the acceptable cognitive load limits? So those are some questions that drove me to put these principles to doubt them a little bit during a very concrete project, which I'll share with you. And I'll just start with giving you some conclusions. So, domain-driven design. I don't have time for domain-driven design. I've said it myself a couple of times, and I've heard it a couple of times. Well, it turned out it's not about how much time you spend on modeling, which is a core part of domain-driven design, but it's how you test your models, which I will give you some examples on. And accepting that not every part of the system will be well designed. You choose where you focus your design effort. And what about the architecture? Well, it's all about the feedback. When do you get the feedback on the architecture choice? And the complexity gives you feedback. Complexity on the code you're writing, the business rules that are changing, is your architecture able to cope with that? So the complexity gives you feedback on your architecture choice. And I don't need test-driven development everywhere. I'm fine with that. It's about your confidence level. So if we are confident enough your code we work with, that's okay. But put yourself in perspective of the reader of the code. That's my lesson here. If we understand how much of the effort is necessary when you read the code, then we can make this conclusion of whether or not we need to amplify our production code with some tests to increase readability. Okay, so that's what I want to come to this conclusion during this story. So for myself, my name is Mufrid Krillic, as this fancy widget showed you in the beginning. And somebody along the path tagged me as domain-driven design enthusiast, which is a great thing. So my consultancy co-work here in Norway, we do a lot of domain-driven design. We're also renowned for this title. And please feel free to reach out. Always nice to meet some new people. And hopefully this story will spark some discussions and interactions. So to engage, I would encourage you to go to Menti and for every questions or comments you might have. So please go on Menti, write it down. I'll get back to you after the conference or during the conference, and I'll publish them. And the goal of the talk is not just you to listen to me, but to spark some discussions and interactions. So hopefully, if you engage, so we'll be able to communicate even beyond this talk. And as I said, this talk is about doubting my principles. And more often than not, I found myself guilty at situations when I was a senior member of the team and new people come along, and then I say, okay, this is the way how we do the things in my team, right? These are the principles, these are the guidelines, we do this, we don't do that. And please follow this because there are some good reasons about it. So these are my principles. However, you can look at it at not so, maybe don't need to be so serious about it. These are my principles, and if you don't like them, I have others. A great quote by Groucho Marx. So let's start this story by questioning three principles: domain-driven design, architecture choice, and test-driven development. So let's start with domain-driven design. So how much domain knowledge do you need to get started? So let me just share the context of this story. So a client of us approached us and asked us, we need a system that will help us communicate with our employees in case of emergency or where our traditional communication channels are unavailable. So we use text messages that are regarded as more reliable and other communication channels. Okay, seems like something doable. And they said we have this HR system, which is employee data owner system. We have all the employee data there. We can use that. And can we connect to some SMS gateway to interact and send SMS messages? Okay, seems okay. So there is this case of emergency, traditional channels are unavailable, we want to use text messages, and we have this employee data owner that we can use. Great. So what about domain-driven design? Well, there's domain analysis and domain modeling. Let's understand the real needs of the stakeholders who use this by doing domain analysis, and use the secret ingredient of domain-driven design, which is language. Use domain language to model the boundaries in your system. That is kind of the magic trick of domain-driven design. However, one recommendation from domain-driven design is really inspiring to me, is that don't stop at the first model. There are always different ways to look at things. There are always different solutions. So why do you stop at the first solution, the first model? Try to explore it a little bit more. But in this case, do we need domain-driven design? I mean, do I need domain analysis? I believe I understand the problem. Do I need all this modeling, spend time on modeling? How complex is this problem actually? Okay, so we afford to go have one more conversation with our stakeholder. That's okay. So we went back and you told us something about this emergency and crisis. No, that's not important. Disregard that. What is really important is, in any case our traditional communication channels are unavailable, then we want to send text messages. Okay, so don't need to think anything about crisis, emergency cases. No, just disregard it. Okay, great. And we focus on this HR system, but we did disregard this SMS gateway. It's more like solution proposal than a problem definition, right? So we actually decreased the complexity here by talking with our stakeholder. So don't need domain-driven design. There's not much language going on here. Just straightforward application. But this recommendation to not stop at the first model. Okay, let's give it a chance. Are there different ways to solve this? Okay, first thing, let's just do what they recommended. Connect directly to this SMS gateway. So here's this sketch, whatever, not too much formality into this diagram, information model, whatever. So, okay, this works, great. So our application would fetch all employees and phone numbers from this HR system on the startup, and they will send SMS, Merry Christmas to everybody to this SMS provider system. So we woke up, we fetch all the phone numbers and employees, and we send SMS messages to everybody. Maybe we need some internal database in case this HR system is unavailable. This could work. Are there other ways to solve this? A colleague of mine mentioned that this, to me, seems that this problem has already been solved by somebody else, at least in part. And it turned out that there was a second way, another way to do it. So we found this third-party SMS service that can be customized for enterprises. So our application, instead of sending SMS messages, would again fetch all these employees and phone numbers, and will update the employee groups in this third-party system, which would allow somebody from our client's user to start the SMS process to send either to everybody or to the employee groups. So this is a little bit different perspective. Now, what's most interesting about this one is that it revealed some complexity. So what are employee groups? That was not mentioned before. So just by doing a little bit of modeling, seeing things from a different perspective, we'll learn something new. And it turned out that our client's organization was not just one organization. It was divided into several sub-organizations, and employees could be contracted on one sub-organization or different or multiple. They could change, they could leave, new employees come in, of course. So there were these dynamics between employees and the organization structure that we saw only on the second model. So that was good. So DDD, a little bit of DDD inspiration was useful. We revealed the business model more clearly. However, proper domain modeling we did, I don't know. And could we get even better with the third model, the rule of thumb, try 3 models? Well, here we stopped a little bit, because this was this dilemma of multiple models versus speed. And I had a great chat with Jason Gorman about this. And as Jason said, for him, to discover what customers really need is to give them what they want immediately, quickly. Don't discuss. Go to production as soon as you can, and then you iterate. Oh, that's what you didn't want this. Okay, what you want? So we decided, okay, we are going to deliver something. We go to the production with our second model, which was our choice, and we don't spend more time on discussing. Let's find out. So the answer for do I have time for domain-driven design is, well, you're probably doing it anyway. It's about how you test your models. We always have to do some kind of modeling. We need to abstract the reality. We can't put the reality into our code. We can't put physical employees into our system. So we need to abstract them. There's always some degree of modeling, but how do you test your models? So you want test to delivery, perhaps the best way. However, not always it's possible. It's not always possible to deliver enough of enough to learn what you want. So you need to challenge alternatively some more scenarios. So domain-driven design turned out to be useful to some degree. So what about choice of architecture? Well, let's go with hexagonal architecture. Why? Okay, what is hexagonal architecture? We'll go to the source. Alistair Coburn introduced this concept to us, where you try to develop and isolate, develop and test your application in isolation from external concerns, whatever they might be, And those external concerns are abstracted away from the application itself through a set of adapters. This architecture style also called ports and adapters architecture. So the idea is to be able to test and develop your application, your business rules in isolation from everything else. And as this is the way Alistair put it, he allows the application to be driven equally by different concerns and still keep it isolated. So what does this mean concretely for us, in our case? Okay, let's have a look. So we will have some kind of domain model with business rules in the middle, and we will interact with them through different layers. And the model itself, we need to interact with some external dependencies, and we'll do some dependency inversion to have dependencies point the right way. And on the other hand, or just differently, the same picture differently, we will call this domain model, which will have two adapters as per ports adapter architecture, one for the HR service, which we call employee service in business language, that will implementation of that adapter that will communicate with the HR system, and we'll have this SMS service which will communicate with external SMS service API. Okay, so that's another sketch diagram, whatever you call it. At some point, your architecture needs to map to your code structure. So how did we do that? Well, in your programming environment, you can use any abstraction you like or you have available. So in this case, we use namespaces as abstractions on the code level. So we had a designated namespace for entry of the application. At Kickstart was used Amazon Lambda functions. So that code was there in entry. And we have this application service that called our domain model. And then we had a separate namespace for external code that interacted with external services, this HR system and SMS service. And the domain model was accordingly designated its own namespace. So we had these adapters, and summary business logic was put in one place. The business logic to keep these two data sources in sync. Great. But the real consequence of choosing hexagonal architecture was dependency flow. So we put some rules and some constraints on how do we want this application to evolve. So we don't want any dependencies going from the domain namespace outside. So all dependencies, we want to go towards domain. Wherever you are, you can always depend on something within domain, but domain namespace code will not know about anything else. So we are imposing constraints, more rules, more structure, which means we are requiring more discipline from developers. Now, is that necessary? Are all those rules necessary in this case? Well, does this business choice, this business complexity justifies our choice? So there we get back. Can we get feedback on this one, on this choice? Can domain complexity tell us something about it? Well, there was this thing about this concept, employee groups. We didn't fully understand it. What is this dynamics between employee groups and sub-organizations and sending SMS messages to only certain employee groups? And we stumbled upon this quote from Dave Farley. What is about evolutionary software architecture? There are always parts of the system you don't fully understand. And when you don't understand something, that justifies its own abstractions. You abstract it away so you can evolve it along with your understanding. So how many things are we uncertain about? Let's see. So we are uncertain about how to keep this employees' data with employee groups and SMS groups up to date. And according to Dave Farley, okay, let's put some abstraction around it. Okay, so these are our abstractions, how we approach the problem through a set of abstractions. So first we ask questions. Where are employees contracted today? So we sort employees by these organizations. Where do you belong? And then we decided to reflect the structure of how our client's organization was structured to this SMS group. So that was our choice to model the employee group concepts. We reflect the organization structures to SMS groups. And then all those changes in employees, when they switch organization, they get new contracts and they old contracts, we try to synchronize those with the designated SMS groups that were reflected from the previous step. And this turned out not to be trivial at all to do this synchronization step. So instead of just saying we are finished, we are returned, let's go on, we decided to present a small report for somebody at our customers to be able to monitor and intervene if necessary. So we accept uncertainty and complexity, and we create abstraction around it. So the business logic is okay to be abstracted because there is some certainty, some complexity here that needs to be dealt with. However, there is one thing that we were not certain about, not everything else. So we actually perhaps needed only one abstraction. Does that justify the choice of hexagonal architecture? Because by choosing hexagonal architecture, we are imposing all these rules about how the different parts of codes are interact with other parts of the code. But there was only one part of the code that we were uncertain about. So should we have waited a bit more and introduced something less rigorous than hexagonal architecture? Okay, let's say, take a look at the last principle, test-driven development. Perhaps test-driven development can lead us to another path, or can show us where we get most value by writing tests. It's all about, for me, it's how do we reach that good enough abstraction layer. So what are the abstractions we end up with, what we are satisfied with? Again, keeping in mind this quote from Dave Farley. And so how do you understand your domain? And this happens all the time in conversations with stakeholders and domain experts. For some reason, a lot of us like to speak in terms of rules. If you do that, then you do that. And if that happens, then that happens, and so on. And that's how, of course, our code eventually turns out to be. It's a set of rules. However, to understand domain deeply, to me, the more complex domain is, the better is to understand in terms of examples. So when you start talking about rules, I ask you to give me examples. So it's better to have more examples, as I see it, than fewer rules. So, and we had this, again, this dynamics of employee groups. So there are tons of rules there, of course, but how do we get to those rules? How do we understand them? Well, we understand them through a set of examples. And that's what our tests are. Nothing more, nothing less. So each test on the area of uncertainty, each test is an example itself. So we just had a dialogue, conversation with our stakeholders. Give me some examples of things that are peculiar or difficult or whatever, and we write a test. So these are some examples, some tests that we actually had in our code. What happens if an employee exists twice in the same group with duplicate phone numbers? Somebody doesn't have a phone number. Why? And there are two people with the same number. Why? So, but it happens, and you deal with it. You communicate with your stakeholders, and then you implement the solution for those examples in your production code. So, as a rule of thumb, your tests go more and more in specific directions, more and more examples, while your production code goes more and more in generic direction. So we we embrace this uncertainty with test-driven development. We explore domain, test-driven, setting up scenarios. That reveals the complexity, slowly but surely, one test at a time. And there was a difference between the two approaches. So we had this abstraction first approach. So now we dealt with the problem by creating a model early. So these are abstractions that we need to understand to get to the bottom of it. However, when we did this, one test at a time, one example at a time, one scenario at a time, we just kept on implementing, and our code ended up like this. And I don't require you to grasp the nuances of this in just a couple of seconds. It's actually quite similar to this one. I'll get back to it. And these are, of course, abstractions as well. The code is always an abstraction. But those abstractions are arguably on a lower level than these abstractions. These four abstractions, we talk about how we perceive the dynamics between employee groups and sub-organizations, and how we need to reflect these dynamics into these SMS groups that can be sent only to certain employee groups or to everybody. This is the same in this one, but this was driven example by example. And now this dilemma, when you have this refactor step, of course, in test-driven development. You have this dilemma of, okay, should I refactor it towards a higher abstraction level like this, or should I keep it like this? Actually, we kept it like this. Hopefully for good reasons. Because, again, we asked some questions. What do we gain by introducing more abstractions? And this notion of cognitive load kept popping up. So when you read the code, you put yourself in the position of a code reader. When you read the code, will that require more or less effort from the code reader if we introduce the abstractions, if we keep the abstractions on a higher level, or if we just have them all together like this? And so this is the real guideline here. Not writing the code, but reading the code. Will the abstractions provide anything extra to the code reader? And another thing that I myself quite often guilty about, I get, sometimes I like my own abstractions. I am committed to it. So, and whenever that happens, I stop and why I'm committed to this abstraction? Are there any other ways to do it? So don't feel too committed to your abstractions. Maybe they are not as valuable to somebody else or to yourself after some time you read your own code as you might have thought at the moment. So, and it's all about, when I talk about cognitive load, it's more about this, what you call the working memory, how many things you can keep in your working memory at a time. And it's also personal, and it's individual. Somebody is able to keep much more things in their working memory than somebody else. But we think in terms of average developer able to read my code. So we ended up like this. As I said, this is actually the same as those higher abstraction levels, because we have this HR employee service abstraction here, and then we have how reflection of organization structure and employee groups here, and then we try to synchronize it, which was not so trivial, and then we create this small report. So this is the same as this higher level abstraction code, but we kept it like this because we are consider this to be necessary for somebody reading the code to understand the whole picture. Instead of jumping back and forth between those higher level abstractions, you keep everything in one place. So TDD did help us modeling the parts we didn't understand, one abstraction at a time. And how about the hexagonal architecture? Did this process of TDD give us any feedback on our choice of hexagonal architecture? Well, in hindsight, since there was a lot of uncertainty about how to keep these concepts in sync between employee groups and SMS groups and organizations and contracts and sub-organizations, whatever, I still believe that we need to hold the domain code, the business rules, separate from the rest of the application. However, I would relax all the other constraints. So I would relax constraints on everything else. So you could have just two levels of abstractions, domain and everything else. And then you let everything else evolve in their own way. So let the team discover their own rules, set their own rules instead of imposing the rules from one certain architecture style early on. So that's the way, that's the feedback we got on hexagonal architecture. We could have done this thing a little bit more relaxed. And do we need test-driven design everywhere? So concrete example from this application was this part of the code. Now, this is different than the listing I showed a couple of slides ago, because I assume that most of us with a little bit of experience are able to understand it rather neatly. And the guideline here we use, if I and my colleague are able to discuss about this code, understand it, without being in disagreement too much with each other about what happens here, then the cognitive level is acceptable. And adding more tests perhaps does not provide any more value. And in this particular case, we were posting this report to the Slack channel, which was how we reported back to our clients. And to test this, we actually need to post on the Slack channel to see it work. So we could mock it away, and we didn't see any value of doing it. So in this case, the cognitive load is acceptable. There are not too many lines of code. We are able to understand this just by reading it. And then we felt we don't need more tests to add any more value to this part of the code. So we didn't have complete test coverage, but we felt okay with it. So the TDD is not needed everywhere. Whatever is standard code or the edges, this was example code on the edges. But just remember about this cognitive load. So if you're uncertain about cognitive load, if you don't have your confidence level, so then you add more tests. And domain-driven design actually fit nice into this, because not all parts of the domain will be well designed, as Eric Evans put it. And so we accept that certain parts of the code, that's where we put our design efforts, and then we relax the constraints on other parts and see how they evolve. Okay, so let me wrap up. Also, what are the questions I would recommend you to consider in your own context? So, for you, ask your questions. Ask the question, how complex is the problem space you're working on? Do you really need deep domain analysis? Or you can combine domain analysis with delivering your models. You model something, and then you throw it in production and see what happens, and you learn from it, iterate from it. The ability to iterate is important. So, choice of architecture. Can you do this evolutionary approach? You defer the choice. You impose constraints only on parts of the system that you're uncertain about. And then you let other parts of the system evolve in their own fashion. And tests are a great thing to explore uncertainty. If you formulate your tests as examples, that leads you to, it gives you more answers for each question, so you learn more, and you get more answers, you increase your understanding. And abstractions on every level, abstractions in your code structures, abstractions in your code itself, keeping in mind cognitive load of the reader, not while writing the code, but reading the code. What will reader of the code need to understand your code? Is another abstraction helpful, or does it hinder the reader of the code? And this is everything. Just on one slide, if you like to. I'll put the slides out there, of course. And now, this is all fine and good. Somebody might see it, this talk as important, I don't know. But now for real important stuff. What's really important for me, as I feel really important for us as a community, is to contribute to the new generations to consider their careers in science and technology. And one of the best ways, if not the best way to do it, is first LEGO League. So some of you are familiar with this, but perhaps not everybody. So we try to inspire children, 10 to 16 years of age, to choose careers or consider careers in science and technology in the STEM field. And I encourage you to get engaged. There are teams all over the world. You can be a mentor of a team, as I am, or you can consider just being a judge on a competition. It requires only 1 day of your time. Or suggest for your employees to be a sponsor of first LEGO League competition or teams. Teams need funds. My current employee and previous employee, both are sponsors. And just to show you how fun this can be. So now, this is the competition. And this is their robot. And they have 2.5 minutes to complete as much assignments on the robot mat as possible. So they start the robot from this area, and the robot goes on and do this autonomously on the robot mat. And this is just 2.5 minutes. It's really exciting, and this is me. This is what I do. I'm there a couple of meters away, cheering for them, spending all my energy. However, these are rather unpredictable moments on the robot game, so sometimes it goes like this. So, this could be real fun, and at least what you can do now before we leave. This is my current team, Team Mission Possible. 2 guys, 2 girls, 14 years old. They have a GitHub account. They program in Python. Please follow us. They would be very glad. This is our robot, and thank you.